Morning again. Welcome to this session. It seems as people are not attending. I don't know why. Or they are still writing even today. Anyone? Oh, okay. Okay, fine. So, but that doesn't mean that if you are writing, you don't have to attend class. You're supposed to attend a class. It's very, very important because you'll be left behind. Okay, let's continue with our work. You can recall that I have introduced the method for estimating the parameters on the process. If you still recall, I've introduced three methods. I've introduced three methods on how to estimate the parameters. The first one is a MME called method of moment estimate. That's number one. Number two is the least square estimator method. Number three is the maximum likelihood method. And I said maximum likelihood method, we're not going to apply it. However, we're going to consider only two methods. That is the MME and LSE methods. Now, we have already covered the MME method where we estimated the parameters for autoregressive process, both autoregressive of order 1 and of order 2. Then I said for the moving average of order 1 to estimate the parameters, please just go and do it as a homework or as an exercise. I don't know whether you managed to do that. Is there anyone who managed to do that? Estimating a parameter on the what? On the moving average of order 1 process. Have you done that? Anyone? Moving average of order 1, which is written as xt equal to zt plus theta 1 zt minus 1. Okay, so we just want to find the parameter. Which parameter are we talking about? Is theta 1 estimate. This is the parameter that we wanted to estimate. Parameter theta 1, we just want to estimate it using MME method. So remember, for MME method, I told you that for xt, you have to change it to be rho k, and xt minus 1, rho k minus 1, and xt minus 2, rho k minus 2, and so on. But if you can check this moving average of order 1 here, it has only xt. It doesn't have xt minus 1, xt minus 2. Rather, it's having zt minus 1. So it's very difficult to come up with the estimated parameter in this regard. So what do? You have to start by calculating the autocovariances, and then later you find the autocorrelation functions. Then you convert those autocorrelation functions so that you can calculate then you use those autocorrelation functions so that you can be able to estimate the parameter. Are we together? So who can tell me what is the autocovariance at leg 0? In other words, what is gamma 0 there? What is our gamma 0? Anyone? Gamma 0. We've already calculated this one. I think it's for the third time now. Calculating gamma 0. So, but
It's
anyway,
sigma
come again.
plus sigma squared
Mm.
plus theta 1 squared sigma squared.
1 theta 1. Okay. Like this.
Yes.
Okay. Gamma 1. Gamma 1. Anyone?
It's not theta 1 sigma squared.
Yes. Theta 1 sigma squared z. That is your gamma 1. So then you have to find rho 1. That is the autocorrelation function at leg 1. Would be equal to what? You know that is equal to gamma 1 over gamma 0, isn't it? So obviously you are going to have theta 1 over 1 plus theta 1 squared. So this is the what do you call it? Autocorrelation functions at leg 1 is the one that we are going to use to estimate our parameter theta 1. We're going to use it to estimate this one, parameter theta 1. How? So what you have to do, because we are estimating, you can just say the estimated autocorrelation functions at leg 1. So it's rho 1 estimate is equal to theta 1 estimate divided by 1 plus theta 1 estimate squared. You see this one. So we are going to use this one to estimate the parameter. Remember, we're using MME here method. We're using MME method to estimate the parameter theta 1 in a moving average of order 1 process. Okay. So how do you do that? So you just cross multiply here from this one, question star. You have to just cross multiply. Okay. So you're going to get what? This implies that you are going to get rho 1 estimate plus rho 1 estimate theta 1 square estimate, okay, which is equivalent to what? To theta 1 estimate. Are we together? Then from there, remember, we just want to find the estimated parameter theta 1. How do we do that? So this implies that can rewrite it as rho 1 estimate theta 1 estimate square plus let's say minus theta 1, so that it can be an equation, then what? Plus rho 1 estimate. This is equal to 0. Now this one is a parabola equation. In other words, in this regard, you have to find the roots for theta 1. Okay, so how do we do that? You're going to use the formula. You're going to use the formula, then later you have to find theta 1 estimate to be equal to something. Because it's a parabola, you're going to get two of them, or theta 1 estimate equal to be something else. So I will leave it here, but anyway, you are going to find theta 1 here. Estimate is equal to, is it equation is it minus b plus or minus the square root of b squared minus 4ac, if you still recall, then divided by what? By 2a. It's like this, isn't it? So just go and fit in this equation using that parabola equation. and then you find the estimated parameter. So this is for you to do. Any question? None. Okay. So now we are done with the MME method. Now we are continuing to the what? LSE, least square estimators. So we are going to use it to estimate the parameter of autoregressive of order 1 and autoregressive of order 2. Okay.
Say,
So we are yes.
oh, sorry, I want to ask about when we start introducing those head. Is it fine to introduce them anywhere, or we introduce them after equating to 0?
And in this regard, you can just start it anyway, yeah, especially in this equation number 1.
Okay, no problem. Thanks, sir.
Yeah, or this one, just start from equation number 1. Okay, let's quickly go to the least square estimator method, and then we estimate the parameter of autoregressive of order 1.
Sir,
Then, yes,
what about the MA2 process?
MME2. You are going to have two equations. Remember, here is only one equation because you have got only autocorrelation functions at leg 1. Because here you have got only row 1 as you have a moving average of order 1 process. Okay, if you have got a moving average of order 2, you are going to have row 1 and row 2. Okay, so you are going to have two equations here. Then you equate them. Then later you find the parameters. You get that? So, but anyway, let's just go to the autoregressive process where I'm going to show you when you have two equations, how do you equate them together? But I know, you know, this is mathematical. You know how to equate two equations when you want to solve for something else. So let me just go to the least square estimator. We are going to apply something like this, and then you will see how do you equate the two equations. Is it fine?
Yes.
Yeah.
Okay, okay, it's fine. Let's go there. Let's go to the second page. Here we're going to apply the LSE method. LSE is the least square estimator method. So in this regard, we are going to apply LSE method for autoregressive of order 1. So remember, in LSE method, we are automatically going to minimize the sum of square of the difference. We minimize the sum of squares of the difference. So here, we are going to minimize the sum of squares. Sum of squares the difference of the difference. What difference are we talking about here? It's xt minus xt minus 1. So we are just going to minimize the sum of squares of those xt minus 1. So let's quickly go to the process autoregressive of order 1. Okay, given by xt equal to, let's introduce the parameter here, mu plus phi1, okay, open brackets, xt minus 1 minus mu plus zt. See this one. This is the autoregressive of order 1 with parameters. You see, we introduce mean, mu, and parameter phi1 there. So we have got how many parameters? 2. So what do we want to do? What do we want to do is to estimate mu and phi. We want to estimate, let's say phi1 and what? And mu. Those are the two parameters that we want to estimate there. Okay. Using what? LSE method, where we are going to minimize the sum of squares of the difference. So now, where do we start? Because we want to minimize the sum of squares for ZT, we just write ZT as the subject of the formula. First, write ZT as the subject of the formula. So now this implies that ZT will be equal to what? XT, okay, minus mu minus phi1, open brackets, xt minus 1 minus mu. Isn't it? So here we're minimizing the sum of squares. That is why here at the end of the day, you are having st, then you subtract xt minus 1, even though there are parameters there. So this is what you're supposed to do. That is the first step for using LSE method. You minimize the sum of square of the difference. This is what we did. Then from there, so now the sum of squares, which is s, represented by s, sorry, s, because we have got two parameters, phi1 and mu, we are going to have phi1 and mu there. This is the sum squares, which is equivalent to sum of squares for zt, okay, which is equivalent to the sum of xt, okay, minus mu minus phi1, open brackets, xt minus 1 minus mu, close brackets. So let me just use the bigger brackets here, sorry, show that the summation is covering everything there. Okay, then you square it. Okay, this is the sum of squares. We just want to minimize that. Then later, the third step, you find the difference. What do we call it? Not difference, derivative, yes. Then you find the derivative of sum of squares. How do you do that? Derivative d of s by 1 mu. So we are deriving with respect to what? It's either with one of the parameters. First, with respect to mu. ds phi 1 mu d mu. I think you are familiar with the derivatives. In mathematics, we did that. Then you equate this derivative to what? To 0. So that you can find those parameters, phi1 or mu1. But because in this regard, we are deriving with respect to mu, so we are going to consider the mu there. Okay. So now, the derivative of s phi1 mu with respect to mu is equal to what? Can I go to the second page?
So you said
Remember
you
when you
derive what?
drive, okay, when you drive, so you are going to take this to this side, and then we derive anything which is within the brackets. So how do we do that? Let's go there to the next page.
So
Yes.
when you derive, what are you deriving now? The last part.
Yeah, the last part.
And then what about the
Yes.
mu in the middle?
Hey, we're going to derive it as well because it's with respect to mu there. Can't you see? Let's do it. So you can tell me, isn't that you know how to drive? This implies what? So we're going to have 2, isn't it? The summation of what? Tell me.
Open brackets -1.
-1. No, we are driving. We're starting with this one.
Okay, the long one is xt minus
Xt
mu.
minus, yes, I need that one. Sorry. Yes, I need that one. Xt minus mu, ne?
Minus mu
Eh?
minus
Yeah?
minus Taiwan
By 1. Open brackets, ne?
into is xt minus 1 minus mu,
Okay.
and then
So
its
we
derivative
yeah, we drive. Then we drive something which is inside is what?
is -1 plus
Yes.
Taiwan.
Yeah, that's very nice. That's good. This is how we derive it. Then you close the brackets for the summation, then you equate it to 0. I think we are together, isn't it? Now, what is left is just to, so you can divide both sides by 2, isn't it? Then you're going to be left with summation again, then open brackets. Now, to be more simpler, for those who don't even follow, I think you have to take -1. See this -1? You multiply through here for each and every one. Then when you are done, you take phi1, you multiply everything there. Okay. So we're going to do it like this. The first one is going to be minus xt, okay? Then plus mu, then plus phi1, open brackets, xt minus 1 minus mu, close brackets. Then we are done with the -1. Then you come to the phi1, you multiply through again. It's going to be plus phi1 xt, then minus phi1 mu, then minus phi1 squared, open brackets, xt minus 1 minus mu, open brackets. Then you close that big bracket and then you equate it to 0. We're still together. Then later, I just want to make it simpler for those who don't even follow so that you can understand better. Then you open the brackets again here. Here, you open the brackets here and here. Okay, let's do that. So remember, there are many methods of doing this. So I just want those other ones to understand. So it's xt plus mu plus phi1 xt minus 1, isn't it? Minus phi1 mu, okay, plus phi1 xt minus phi1 mu minus phi 1 squared xt minus 1, okay, then plus phi 1 squared mu, isn't it? Then we close, then equate it to 0. Is it correct? Okay. Then continue like that. Then let's do in this way so that you can easily see. Let me just take those that are having xt on the same side, those that are constant on the same side, so that you can see what we can do. So we're going to have minus xt plus phi 1 xt minus 1 plus phi 1 xt minus phi 1 squared xt minus 1. Okay, we're done with those that are having xt. Okay, then comes to the constant, then plus mu. Okay, then if you can check, we have got this and this, isn't it? They are the same. You can add them up and then you get what? Minus 2 phi 1 mu. Okay, then we are left with that plus phi 1 squared mu, then equate it to 0. Okay, still okay. Then later we can try to group. If you check this one, you can find a common factor with this one. Okay, the same applies to this one and this one. Okay, then later these ones you just find the common factor as well. Okay, so let's do it. Okay, I think we can have a space here. Let's do it. This implies that summation still remains open brackets. So for minus xt and plus phi 1 xt, you can take a common factor, which is what xt is in it. So you can take xt out, open brackets. See now. Yeah, xt open brackets what? Minus 1 plus phi 1. Are we together? You do the same for phi 1 xt minus 1 and minus phi 1 squared xt minus 1. Get a common factor. Let me take a minus phi 1 xt minus 1 as a common factor. Then open brackets. So here you're going to be left with minus 1. Then you said plus phi 1, isn't it? So our main idea here, because I said minus there, because I said minus here, I just want this, okay, and this to be the same, so that it can be easier when I continue solving it. So that's why here I'm having a minus here. Okay, I think it's clear. Then later, the next, we go for the mu now, the one that are constant. So you're going to have plus mu, take it out as a common factor. Okay, then you are left with 1 minus 2 phi 1 plus phi 1 squared, isn't it? Okay, and again, because this one is 1 minus 2 phi 1 plus phi 1 squared, can also be written as Let me show you. Can also be written as what? Minus 1, sorry, minus 1 plus phi 1 whole square. Agree? Is it taking us back to this one? If it's true, so can substitute this one by this. So let me just remove that one now. So let me just remove this and put minus 1. And then put that one and put minus 1 plus by 1. Then all squared, remember? And then you have to close the brackets. Then you equate it to 0. Okay, so I don't have any space, but anyway, you're going to equate it to 0 later. Okay, so now let's go to the next step. Can I go to the next page here?
Yes, sir.
Okay, so now this implies that who can tell me? So you're still going to have summation again, open brackets. Then what? Tell me. You can't see. X3. Remember here, let me just go back again. Here, you're going to take this as a common factor. Let me show you. You're going to take this one as a common factor, isn't it? This one. If you take it out, then you divide both sides. You're going to be left with xt. Yeah, you're going to be left with xt. I think it's minus phi 1. Is it phi 1? Minus phi 1 xt minus 1. Minus 1. Then what?
Plus mu.
Plus mu.
1
Bracket what?
plus 1.
Remember, here is squared. Here is squared here. So when you take one, another one is going to be left. So that is why you're having mu minus 1 plus phi 1. You get it? Then you close it, equate it to 0. Are still together? Then later we introduce the summation. So let's introduce the summation. You're going to have summation of xt, isn't it? Minus phi 1 is summation, sorry. Summation xt minus 1, isn't it? Plus,
Sir,
yes,
please explain again the first step.
the first one, this one. The
Yes,
one on
on that
top.
page. Yes.
I said, let me just go back again so that you can understand it better. I said for this last step here, if you can check the term within the brackets, this one, okay, is the same as this one, isn't it? Is the same as this one, isn't it? Then you can take a common factor, okay? In other words, what I'm saying is, you're going to have 1 minus plus phi 1. That's a common factor. Take it out. We're going to be left with summation, open brackets, of xt, isn't it? Then minus. Here, if you take a common factor, you're going to be left with phi 1, xt minus 1, isn't it? Then plus mu. Here, if you take that common factor, you're going to be left with what? Minus 1 plus phi 1. Okay? Then you close that bracket, then you equate it to 0. Then later you divide through by what? Minus 1 plus phi 1. Minus 1 plus phi 1. So this one going to divide this one. Here you're going to get 0. Okay. So that's why you are having something like this. Something like this here.
Okay, thank you, sir.
Then later you introduce the summation. So summation of xt minus phi 1, summation of xt minus 1 plus. Then what is the summation of a constant, if you still recall? When you introduce summation here, what are you going to get? Here.
N constant.
Yes, definitely. Thank you very much. You are going to get n mu open brackets minus 1 plus phi 1 close bracket. Then equate it to 0. Okay. Then later you divide through by n. Both sides, left hand side and right hand side. You are dividing by n. If you divide by n, by n, by n, by n. So what are you going to get? You can tell me for the first part, what are you going to get?
The
Anyone?
mean of
Just guess.
xt.
Huh?
Mean xt.
Yes, x bar. You get x bar. We are estimating now. Xt, you know that the summation of xt divided by n is a simple mean, isn't it? So that is why we are having x bar. That is a simple mean minus. Because now we're starting to estimate, this one has to be estimated as well. Okay? So the question is, what is the summation of xt minus 1 divided by n? Summation of xt minus 1 divided by n. Again, is x bar because we're estimating. Just an x bar plus. So this one now, n cancel n, then you're left with what? Mu, because we're estimating, so it's going to be mu hat. Okay? Then minus 1 plus phi 1 hat. Then equate it to 0. Are we together? So then later, here you can find the common factor, which is x bar, open bracket 1 minus phi 1 hat plus mu hat, open brackets minus 1 plus phi 1 hat equal to 0. So now our main idea is to estimate mu hat, isn't it? So you can take that other part to the right. Oh, before that, so we have to do something here because this 1 minus phi 1 hat is different from this one. So we just want this to be the same so that they can cancel each other next. So what do you do? If you are having these that are different and you just want to be the same, what do you do next?
Take
Take
the
minus
common.
1.
Yes, definitely. Thank you so much. So can you just leave this one as it is? 1 minus phi 1 hat, close brackets. Then you said minus mu hat 1 minus phi 1 estimate, then equate it to 0. So we are done, isn't it? Therefore, our mu hat is equal to x bar. We are done. We estimated our mu hat. Now it's equal to the sample mean. So this is how you apply the least square estimator when you just want to estimate the mu. It becomes a simple mean. But we are not done yet, because remember, we still have to estimate what? Phi 1 hat. We still have to estimate this one. Just want to find this one again. We are done with this one, so we are left with this one. So just finish up this one so that we can go to the next step on how to estimate the parameter phi 1. You're done. Can we move to the next?
Yes, sir.
Okay, now we just want to estimate this one, as I've already indicated. So how do we do that? So if you can check, let's go back a bit. Yes, we have to go back to this point now. We have to start here. We have to take this one. We go back to this one and start again. Okay. The sum of two parameters. Now we are going, it has been estimated, remember. So that's why at this time we're going to have phi 1 estimate. Instead of a mu, we are going to use x bar. Okay. Then which is equal to what? Which is equal to what? To this one. Xt minus x bar minus f1 open brackets xt minus 1 minus x bar. This summation xt minus x bar is minus phi 1 open brackets xt minus 1 minus x bar. I think it's like this. Then square. Sum of squares, isn't it? Yeah, I think it's like that. Then later you do what? Find the derivative. So g s phi 1 estimate x bar with respect to what? To phi 1 this time around.
So why did you write the head and
Oh,
X
yes,
bar?
yeah, thank you.
No, why did you write the head and the X bar instead of?
Now we are estimating because we have already estimated this one. We have already estimated this one. So you can just change everything to be estimation. We have already done that. So that is why we're changing everything to be estimated now. We're estimating the phi 1 hat at this time around. Then from there, you derive, find the derivative. Okay, you find the derivative, then equate it to 0. Okay, so which is the same as what? 2, the summation of xt x bar, okay, minus f by 1, sorry, estimated xt minus 1 minus x bar. Then what? You derive those that are within the bracket. Then what is that? You can tell me. We derive the one, and then we have to derive this one within the brackets. It's what? It's going to be minus, okay, xt minus 1 minus x bar. Did you see that? Okay, so this one, let me just use the bigger brackets here. So that's for the summation. These brackets for this one is for this one, and this one is for the bigger brackets. Then equate it to 0. Are we still together?
Yes.
Then you divide through by 2. Then later you're going to have the summation, open brackets. Can I skip that one? We know that we're going to divide by 2. Then later you have to take everything here. You have to take this one, you multiply this and that. So what I'm saying is xt minus x bar. Okay, this is the one, this one. Okay, then we are multiplying with this one. Okay, so we're going to multiply with xt minus 1 minus x bar. Remember, there is a minus here. Okay, so you can just put it outside somewhere here. It's a minus. Okay, then you said minus phi 1 hat, open brackets, xt minus 1 minus x bar. Okay, then you multiply by this one again. It's going to be plus here, isn't it? Then xt minus 1 minus x bar. Then you close the brackets. Then you close the bigger brackets. Then equate it to 0. Are we still together? Then later you introduce the summation now. Let's introduce the summation. You're going to have minus summation of xt x bar. Okay. Xt minus 1 x bar. Then what? Plus phi 1 estimate summation xt minus 1 x bar. We can just square this one, isn't it? Because it's the same thing. You can just square it like this. You can just say squared, isn't it? Then equate it to 0. Are we still together? Then you take this part to the other side, because we just want to estimate this one, isn't it? So we take this part to the right, then we left with phi 1. Remember, it's phi 1 here. Can I go to the next page?
Yes.
Okay, thanks. This implies that phi 1 hat summation of xt? Is it xt or xt minus 1? Xt minus 1 x bar squared. Then it's equal to the summation of xt minus x bar xt minus 1 x bar. It's correct, isn't it? Then you divide through by what? Summation of xt minus 1 x bar. Xt minus 1 x bar. Therefore, your estimated phi is going to be equal to summation of xt x bar xt minus 1 x bar summation of xt minus 1. No, yes, there is a square, isn't it? X bar squared, isn't it? Any question? So the question is, what is this? You can tell me this equal to what? Summation of xt minus x bar, close brackets, open brackets, xt minus 1 minus x bar, all divided by summation of xt minus 1 minus x bar all squared. It's equal to what? Who can tell me? Who can tell me? It's equal to what? Anyone? I think it's equal to something. We did something related to this. Who can just guess anyway?
So
Is it
I
gamma 1?
think is the same
The
as row
estimated
1.
of gamma 1.
The what?
Row 1.
Definitely. That's good. That's row 1. Where is it coming from? Is it coming from? Remember, this one, the upper part or the numerator, this one, it's equal to gamma 1 estimate. If you still recall, don't be confused by t minus 1. At that side, we were using t plus 1. And you know that from the properties of autocovariances, xt minus 1 and xt plus 1 are the same thing. So that is why here summation of xt minus x bar, open brackets, xt minus 1 minus x bar is gamma 1. Gamma 1 in the sense that, let me remind you, remember gamma 1 estimate is equal to summation of xt x bar xt plus 1 x bar. Is it over n? Yeah, something like this. See? And then gamma 0 is 1 over n summation of xt minus x bar squared. Even if it's 1 minus over n summation of xt minus 1 x bar squared, still gamma 0. Like here, maybe you're confused with this one, like this one.
Sir,
Still the same. Yes?
sir,
Now,
where's our break? Where's our
Eh?
break?
No, we are going to finish now. We need a break. I wanted to finish
No,
this.
sir, we don't want a break. Let's continue.
I wanted
Let's
to finish
continue.
this. Then I give you exercise. Then
No
you finish
breaks.
from that. A break is disturbing anyway. I think it's better to finish and then I'll give you that 10 minutes later. I won't take it. Okay, so I think you got it. Gamma 1 is equal to that, gamma 0 equal to that. So here it's like we were dividing 1 by n, 1 by n, and then they're going to cancel each other. So it's the same thing. So that is why I'm saying this one is gamma 1 and this one is gamma 0 estimate. You see that? So gamma 1 estimate divided by gamma 0 estimate is the same as rho 1 estimate. So that is why he said phi 1 estimate is going to be equal to rho 1 estimate. That's it. So this is how you estimate the parameter mu and then the parameter phi 1 for autoregressive of order 1. Okay. So now I can give you the exercise to do. So can you just stop here? Maybe you can do it on your own time. But all the exercises that I'm giving you, please, you have to do them. Otherwise, you will regret. You have to do them. They are very, very important. Very important. Actually, everything that we're doing here, they're important. Exercises, they're very, very important. So you have to do them. Okay, let me just give you exercise for you to do for autoregressive of order 1. Okay, remember we were doing autoregressive of order 1. So I just want to give you another autoregressive of order 1 to find the parameter. Let me say exercise. Number 1. Let me just say find the parameter of autoregressive of order 1. I'll show you what type of autoregressive process I'm talking about. So find the parameter of autoregressive of order 1 using LSE method. Or let me just say find the parameter or parameters of autoregressive processes. Okay, because I'm going to give you another one here rather than referring to only one of AR processes. Okay, using LSE method. Okay, number A, xt equal to phi 1 xt minus 1 plus zt. This one is very simple. Number 2, it's xt equal to phi 1 xt minus 1 plus phi 2 xt minus 2 plus zt. Okay, so for the first one, for number A, here you find this. I want you to find this phi 1 estimate. Here I want you to find phi 1 estimate and phi 2 estimate. Are we together? So you're going to do it on your own time. That's it. I think that's. Is it necessary to give you the solution? In other words, you will be proving.
Yes.
Whether phi 1 equal to
Yeah.
something we want to do.
Yes,
Yeah?
sir.
Okay.
Uh,
So that it can be easier for you. Ne? Let me just give you the solution
You
so
give
that
on the next class.
come
I
again.
was give us
say
now.
not now.
I
Not
was
now.
You give on the
Yeah,
next class.
not
On the
now.
next class.
We'll
No, we
prove them like
verify, sir.
next time.
After you have treated this thing.
Yeah.
No, sir, for verification. We
Sir,
want
you
them
We'll
for
verify on the
verification.
next class.
No,
Eh.
no, no, no.
I was
I think those who are saying that on the next class they are okay, they are right. Because if I can give you the solution, you will be working towards to that solution rather than I just want you to go and struggle. Then on the next class, we're going to give you the solution.
Yeah, exactly. Because we will be robbing ourselves here.
That's true. That's true. Okay, just go and do it. On Wednesday, remember, you're going to write a test on Thursday. Are you aware?
yes.
Are you
Yes.
ready?
No.
The test
What
was
is the
ready
scope?
since March.
What's the scope, sir?
Scope, I told you, is chapter 1, 2, 3. It's the scope of a quiz number 1. Yeah?
1, 2, 3.
It's not what I said. I said it's the scope of quiz 1. What was the scope of quiz 1?
Yes, sir.
Didn't I say it's 1, 2, 3? Oh, anyway, just go to the scope of quiz 1. It's the one that is going to guide you.
No, it's fine, sir.
Okay. So let's stop here. Just please go and do it. And then we're going to talk about it on the next class on Wednesday next week. And let me just wish you good luck for the test number 1 on the 14th. Please practice these things. They are not difficult.